Today we're going to be studying some very special types of functions that have some very nice properties that we like to use a lot in pre-calculus. We're going to be studying the parent functions and shifting. We're going to be able to graph parent functions and shift those parent functions. These are all the parent functions that we are going to be dealing with. Many of these you have already seen before. We have the constant function, which would just be a horizontal line. We have the identity function, which is just y equals x. We have the absolute value function, which makes a v. We have a quadratic function, which makes a u shape. We have the cubic function, which is this sort of squiggle shape. We have a square root function and the greatest integer function. Now, there are certain things that you are going to have to remember about each one of these functions, so it's probably pretty important that you write this down. Every single parent function has 3 important points that we need to deal with. Now, you already know how to graph the constant function and the identity function, but the absolute value function, the 3 important points that you need to pay attention to are the 0, 0, 1, 1, and 1, negative 1. If you know those 3 points, you can continue the shape throughout your graph. For the quadratic function, they're the same 3 points. You just have to remember that the quadratic function is a U shape as opposed to a V shape. For the cubic function, your 3 important points are 0, 0, 1, 1, and negative 1, negative 1. For your square root function, your 3 important points are a little different. They're 0, 0, 1, 1, and then you have to go all the way to 4, 2. Because the square root of 4 is 2. That's the next whole number point that we have. And the greatest integer function, again, it's that step function that we've already talked about. Your important points are still 0, 0, 1, 1, and this time negative 1, negative 1. But you also want to remember where the holes occur as well. So at 0, negative 1, 1, 0, and 2, 1. I'll give you a second to get this written down. But it is very, very, very important that for each one of these graphs, you know these points and can call upon them because we're going to have to be able to shift them. There are 2 different ways to shift a graph. There is what we call the vertical shift, where we shift the entire graph up or down. This K can represent any number, 3, 5, 100, it doesn't matter. If it's plus, you're going to shift it up, and if it's a subtraction, you will shift it down. And here's one. We have the absolute value of x plus 4. So we know this is a vertical shift because it's occurring outside of the function. Our parent function would be the absolute value. It's a V shape. I feel it's pretty important to be able to graph the parent function in your graph. So there's my parent function. Notice my 3 important points are labeled with dots. This entire graph is going to get shifted up 4. So each individual point is going to go up 4 places. So 0, 0 is going to go up 1, 2, 3, 4. 1, 1 is also going to go up 1, 2, 3, 4. And negative 1, 1 is going to go up 4 as well. Whenever you graph a function for me, I expect to see that you know the parent function and you know how the graph shifts. This particular graph would earn you full points. You need to make sure that you circle or somehow indicate to me which graph is your final graph. As our graphing gets more complicated, we'll do much more shifting. And we will end up drawing multiple graphs in the same coordinate plane. Horizontal shifts are a little different. Notice a horizontal shift, it's a number added or subtracted inside of the function. So you'll often see it in parentheses like x plus 2 squared or something like that, as opposed to x squared plus 2. This is a vertical shift, whereas this is a horizontal shift, meaning left and right. An important thing to note about horizontal shifts is it shifts left or right, but it's opposite of the sign. So in this little example I made, x plus 2 squared, it's going to shift not to the right. It's not going to shift positive, it's going to shift negative. So it'll shift backwards or to the left, 2. Let's look at an example of that. This time we have the square root function, the square root of x plus or x minus 1. Now notice this minus 1 is underneath the square root, which means this is going to be a horizontal shift. If it was this, then it would be a vertical shift, but it's not. So I'll start by plotting my parent function. My important points are at 0, 0, 1, 1, and then 1, 2, 3, 4, 2. So there's my parent function. And so, horizontal shifts go left or right opposite of the sign. So I'm going to go in the positive direction or to the right 1. So every single point is going to shift to the right 1. So 0, 0 shifts forward 1, 1, 1 shifts forward 1, and 4, 2 shifts forward 1. And so my final graph is the blue. When we combine the transformations together, we can do it in one step as long as you don't confuse yourself. Remember, inside the parentheses or inside the function is left or right, opposite of the sign. Outside is up and down. And it's the same as the sign. So we have g of x equals x minus 3 squared plus 2. So first off, our parent function would be the function y equals x squared. So that means that I have the u shape, the parabola shape, and my important points are at 0, 0, 1, 1, and negative 1, 1. So purple is my parent function. Now I've got to figure out my shifts. I'll start here on the inside. Since it's on the inside, I know it's a horizontal shift. I go opposite of the sign. So instead of going backwards 3, I'm going to go forwards 3, or to the right 3. The plus 2 is on the outside of the function. So that means it's going to be up or down. Since it's positive 2, I go up 2. So every single point in my parent function is going to go to the right 3 and up 2. So I'll start with negative 1, 1. It's going to the right 3, 1, 2, 3, and up 1, 2. The next one, I'll do 1, 1. It's going 1, 2, 3, and up 1, 2. And 0, 0 is going 1, 2, 3, and up 1, 2. And that's my final graph. We'll do one more together. This is a cubic function, which means that my important points are at 0, 0, 1, 1, and negative 1, negative 1. And it makes this kind of squiggle-ish shape, if you want to think of it like that. So that's my parent function. Now let's pay attention to the shifts. So my horizontal shift is -1, or x minus 1. So I'm going to go opposite of the sign. So again, I'm going to go to the right. I'm going forward 1. My vertical shift on the outside is -3, so that means I'm going down 3. So every single point is going to the right 1 and down 3. I'll start with -1, -1. So to the right 1 and down 1, 2, 3. To the right 1 and down 1, 2, 3. To the right 1 and down 1, 2, 3. And that's my final graph. We'll go over more of these in class. If you have any questions, please write them down. Have a good day.